This video is going to be used to explain how to identify a reaction as an SN1 or SN2 based on the identity of the alkyl halide, nucleophile, and solvent. Now the first thing we need to do is determine the alkyl halide, if it's primary, secondary, or tertiary. If it's primary, then it is always an SN2 mechanism. If it's tertiary, it's always an SN1 mechanism. Now if it's secondary, it always depends on the nucleophile and the solvent, so it's a little bit more tricky. For the secondary alkyl halide, we will have to look at the nucleophile. If the nucleophile is weak, then it will be an SN1 mechanism. If the nucleophile is strong, then it will depend on the solvent, whether it's protic or aprotic. Most strong nucleophiles have a negative charge, and that's how we know it's strong. The common ones we have used are cyanide and hydroxide.
The next step is to analyze the solvent. Solvents fall under two categories, polar protic and polar aprotic. Polar protic solvents are things like alcohols, water, ammonia, basically anything with an OH or NH group, which means it can participate in hydrogen bonding. Polar aprotic groups are not as polar. They're polar enough to dissolve the nucleophile and substrate, but not to participate in hydrogen bonding. These are things like acetone and DMSO. Polar protic solvents with a strong nucleophile will result in SN1 reactions. Polar aprotic solvents with a strong nucleophile will result in SN2 reactions.
Okay, so now let's just look at a brief summary of everything we've learned so far. So, of course, your first step is to determine what degree of alkyl halide you are dealing with. If you have a secondary alkyl halide, we need to look at the strength of your nucleophile. And if you have a strong nucleophile, we have to look at what type of solvent we have. Do we have protic, which would have hydrogen bonding, or do we have the aprotic solvent, polar aprotic solvent, which does not have hydrogen bonding? So let's take a look now at a few examples and see if we can implement these steps in a way that makes sense. So we'll start off with some simple ones. If you look at this first alkyl halide, you see that it is a primary alkyl halide, and we know that that makes it an SN2 mechanism. The next example, we see that this is a tertiary alkyl halide, and we know that that makes it an SN1 mechanism. And here are all the steps written out for those examples. You can see in the SN2 reaction you have the leaving group leaving and your nucleophile coming in one step and forming your organic product. In the second example, where you had the tertiary alkyl halide, you have the leaving group leaving in the first step and a carbon cation formed with the strong nucleophile coming in and forming your organic product in 2 steps. The rest of our examples will be secondary alkyl halides. These are the ones that you have the most complex process with. We'll use identical alkyl halides on these 2 examples. The first one has a weak nucleophile, and the second one has a strong nucleophile, which we know because it has a charge. And so the first one will be an SN1 reaction due to its weak nucleophile. The second one, we have to take a look at its solvent because we have a strong nucleophile. And we see that there is no hydrogen bonding, and therefore this one will be an SN2 reaction. Again, I won't go through it because it's pretty self-explanatory, but these are the full steps to these 2 examples written out so you can test yourself. And then in our last example, again we have a secondary alkyl halide, and we can see that we have a strong nucleophile. Yes, it's on the bottom of the arrow, but we know that that doesn't matter, right? It can be on top or bottom. Unless there are numbers in front of it showing a step, it really doesn't matter. And so if it's strong nucleophile, we have to take a look at the solvent now. And we see that there is hydrogen bonding. You have the NH bonding. So that makes this an SN1 reaction. Again, here we just show all the steps to this, showing the leaving group leaving first, forming the carbon cation, the strong nucleophile coming in, and your organic product in the end. That concludes our tutorial on determining whether a reaction follows SN1 or SN2 mechanism based on identifying your alkyl halide, the strength of your nucleophile, and the type of solvent being used.